In this video, I'm going to talk about solubility and how that relates to solutions. Just a little bit of review of solutions before we start. Remember that solutions are homogeneous mixtures in which you have a solute that dissolves into a solvent. Both the solute and the solvent can be any of the three states of matter, any combination of solids, liquids, or gases. The dissolving itself happens when a solute is more attracted to the molecules of a solvent than it is attracted to the molecules of it within the solute itself. And that when dissolving happens, molecules may or may not separate depending upon whether we're talking about an ionic compound or a covalent compound. Ionic compounds will separate into ions, whereas covalent compounds stay as molecules and then just these individual molecules pull apart from each other. So solubility indicates how well this solute dissolves, how much of it dissolves into a particular solute, how quickly it dissolves. We use words like soluble to talk about a solute that will dissolve in a particular solvent, or insoluble to talk about one that will not. The degree of solubility, though, can vary. Even though if something's soluble, it may be extremely soluble and dissolves very easily in large amounts, or it may only be partially soluble where only a small amount will dissolve. So this level of solubility differs from one substance to another, and it also differs from one solvent for the same substance. To use an example, we have sodium chloride down here, good old table salt. And it is soluble in water at a solubility of about 36 grams in every 100 grams of water. Table sugar, by contrast, sucrose, and that's the formula here, you can get 200 grams of sucrose to dissolve in 100 grams of water. So there's a big difference between salt and sugar when it comes to how soluble it is in water. And if you compare salt in water to salt in ethanol, you can see in ethanol only 0.065 grams of sodium chloride will dissolve in 100 grams of ethanol, which is a type of alcohol. So there's quite a big difference in how soluble different substances are. We also have some special terms for liquids. Instead of using soluble, we'll use miscible. So that means liquids will dissolve into each other, or if they won't dissolve, they are immiscible. Even if a solute is soluble, its solubility in that particular solvent will be affected by the temperature of the solvent, and in some cases, the pressure that is in the environment. If we're talking about solid solutes, you tend to get more of a particular solid solute dissolving in the solvent as the temperature gets higher. This is not true for every single chemical, but for the majority of them, a hotter solute will be able to dissolve more of a solid solute. This is the exact opposite for a gas. You can put more of a gas solute into, say, water in your carbonated beverage at lower temperatures, which is why you want to keep your soda in the refrigerator. And also pertaining to gases, you can get more of a gas solute at a higher pressure, which also pertains to those carbonated beverages that when you pop the top, you hear the hiss of the pressure releasing. In general, solids and liquids are not affected by pressure, but they are affected by temperature. We use the word saturated to talk about a solution that then contains the maximum amount of solute that can be dissolved in that solvent at a particular temperature. And as you change the temperature, that number, of course, is going to change. An unsaturated solution then would have less than this maximum amount for this particular temperature. To give you kind of a picture of it, we talked about how sodium chloride at room temperature will dissolve about 36 grams in 100 grams of water. And since grams and milliliters can be interchanged when we're talking about water, 100 milliliters of water and 100 grams of water will be the same amount. So if we were just to put 30 grams of sodium chloride in our 100 milliliters of water at room temperature, it would all dissolve. You can see that the solution does not have any solid particles collecting anywhere. All of these little solid pieces have been pulled apart by the water molecules. It has dissolved. But you could put some more in there. We're not at 36 grams yet. So this is an unsaturated solution. It has less than the maximum that could be dissolved in it. If we try to dissolve 40 grams of sodium chloride in that same 100 milliliters of water, you will see that there is a little bit left on the bottom, because what can fit inside the water in that 100 milliliters of water is 36 grams. There's 4 grams left over, and so they are just going to collect on the bottom. It cannot dissolve into this solvent at room temperature. If we were to heat up this beaker, we could get the rest of it to dissolve in. But at a particular temperature, the saturation level has been reached. We have a saturated solution. And practically speaking, this is how we tell that we have a saturated solution. There's a little bit of the solid we've been dissolving in still left on the bottom. And then usually we just use the liquid part and make sure we don't pour those little bits of solid into our chemical reaction. This changing solubility or changing saturation point can be shown on a solubility curve. And we have a nice graph here which has a number of compounds present to show you how it can change, how vastly different it can be between different chemicals. Here's our sodium chloride here in the middle with this blue line. And you see as temperature increases, it does become a little bit more soluble. The line does go up a little bit from where it starts here, but it really does not make a big drastic change. So really increasing the temperature of water is not going to change how much salt you're going to absorb in it. But if we look at potassium nitrate, this green line, you can see that it makes a big difference whether we are dissolving something at 10 degrees or at 40 degrees Celsius. You will notice that most of these lines are trending in an upward direction as temperature increases. But down here on the bottom, we see one compound, cerium sulfate, which actually becomes less soluble as temperatures go up. It kind of flatlines after about 40 degrees Celsius. So whereas most chemicals are able to be dissolved in the solvent if the solvent is warmer, that is not 100% the case. There are some that are actually the opposite. So we have saturated solutions, unsaturated solutions, and supersaturated solutions, which contain more than the maximum amount of solute that can be dissolved at a given temperature. The way you create a supersaturated solution is when you take a saturated solution and let it cool down in temperature without disturbing it so that no crystal formation happens. Recrystallization can occur over a slow period of time from a supersaturated solution. That's how we make rock candy, if you've ever had one of those wooden sticks with the sugar crystals on it. Or if you disturb the supersaturated solution after it has cooled, it will occur quite rapidly. We did do this in the crystal lab with the chemical in the test tube, if you remember that particular activity. So it's illustrated in this picture here. We have a supersaturated solution. The end of the stirring rod is coming down to touch the surface. You can see the crystals forming within the supersaturated solution, taking basically the level of dissolved solute in the liquid portion that remains down to the level that would be the normal saturation point at that temperature. If you think about how saturated, unsaturated, and supersaturated fits in with a solubility curve, notice that the line is showing the point of saturation at these different temperatures. So the amount that is at the various points for plotting this line, that would be the maximum amount of solute that could be dissolved at that particular temperature. For example, we can pick this point way up here, and so 150 milligrams per milliliter, that is the unit for this particular graph, would be how much solute that would dissolve at this temperature, which looks like it's about, say, 73 or 74. But in this graph, any area below the line, so instead of having, say, 150 at the temperature of 74 degrees, we only had 100, that would be an unsaturated solution because you could add more. And on the opposite way, say if you had 200 milligrams dissolved in it, well, you had created a supersaturated solution, probably by heating it up to this point, almost 80 degrees, and then letting it cool down to 74. And so this extra amount here is basically just waiting to become a solid crystal. If you give it enough time to happen slowly or disturb the container of your supersaturated solution, it will happen more quickly. So you can use the solubility curve graphs along with your information on how much has been dissolved to indicate whether the solution is saturated, unsaturated, or supersaturated. So in summary, remember, solubility is a measure of how well a solute can dissolve into a particular solvent to make a solution. Solubility is affected by temperature and pressure, especially for gases, but solids will be affected by temperature, and that solutions can be categorized as unsaturated, saturated, or supersaturated, depending upon how much of the solute has been dissolved into a particular solvent.